Hello, and welcome to today's session where we're talking about Terramar. So we have a better understanding of how this technology is more than just stress mitigation. I'm Dr. Brian Cornelious, Director of Economic Training with Agrison, and I want to welcome you today. So as we get into this session on Terramar, I want to first just give a brief introduction to what Terramar is. And Terramar is a foliar technology that is designed to improve nutrient uptake and efficiency, enhance stress mitigation, but also optimizing plant health, whether it's photosynthetic capacity or plant physiological functioning, nutrient acquisition. And the way we're doing that is by building photosynthetic capacity and then preserving that additional sucrose that we built during that build phase, while at the same time always utilizing the stress mitigation functionality associated with Terramar. So as you know, Terramar has two very distinct components. We have a marine-based component from kelp, and we have a carbon-based component from leonardite, and they have very different chemistries associated with them. You can see the mass specs of both of those. But what I want you to really hone in on and understand on this slide are what those chemistries, those functionalities, what are they associated with related to plant growth. On the marine based side, a few of them here are highlighted: potassium uptake, stress tolerance, chlorophyll content, nutrient transport. On the carbon based side, from the leonardite, we've got carbohydrate, lipid, and protein synthesis. We've got carbon fixation. That's going to be a big one, guys, as we go through this, as we're talking about building sucrose, that carbon fixation. And then, as always, that nutrient use efficiency. But the key here is that we get synergy between these two components when we put these together, and we see more than we see with any one component by itself. So let's dive a little bit more into this. How does Terramar enable a more robust, better equipped crop in any growing environment? Terramar helps plants take more nutrition in, utilize that nutrition more efficiently, regardless of what the weather situation may be. Because what we're doing, as you see here highlighted in green, we're going to build that photosynthetic capacity, which ultimately fills the gas tank for a bigger, stronger plant. And how do we do that? Again, photosynthetic capacity, increased carbon fixation, better nutrient uptake that gets us into that stage of the crop where we're determining yield. And then the preserve functionality is how does Terramar, through the reproductive stages of the crop, uh, more efficiently utilize that sucrose that we created, or that increased amount of sucrose that was created during the build phase. And part of that could be, did we improve water transpiration? Did we lower canopy temperatures? Did we improve stomatal conductance? How did we get more of that sucrose to the finished plant parts, whether it's grain or biomass, as opposed to it being burned through processes like respiration when crops are under more stress? So just to give a graphic illustration of what that looks like, the build phase, just think of your gas tank. We want to fill that gas tank. And again, here we're talking about photosynthetic capacity to create more sucrose. And then we want to preserve that by getting that to finish yield components. And basically that talks about efficiency. How much more efficient are the plants with Terramar than without? And you can see there, are we getting more miles per gallon with the Terramar versus without? So let's look at that a different way. This is a field trial, 10 fields across the Midwest, in Illinois, Indiana, Iowa, and Ohio in 2025. You can see a control that had no Terramar. And then you can see a V6 application, a V6 and a VT, and then a VT. And what we're measuring here is the amount of sucrose in dry plant mass. And you can see with each one of the Terramar applications, we increased the amount of sucrose. The early V6 and the V6 plus VT were the two highest, but we still saw an increase with the later application compared to the grower standard where there was no Terramar, indicating that maybe that later application didn't have enough time to do what it potentially could do, but it still did better than the grower standard practice. Now here we're looking at the same 10 fields with those same Terramar applications, but now we're looking at how much of the actual sucrose was it was needed for per gram of plant mass. And you can see again here, the grower standard, it took more sucrose, so less efficient than it did for the V6 application, the dual application at V6 and VT, or that VT application alone. Again, more efficient use of that sucrose that we built during the build stage, and we're preserving that for yield or yield components or yield potential at the end of the season. Another way to look at this, in the same 10 fields, each one of those applications gave us a yield increase. But where did those yield increases come from? And as we dig deeper into this data, what we're seeing is the areas of these fields that were lower producing, that were more prone to nutrient stresses or weather related stresses, those are the areas where we saw the greatest gains with this Terramar technology. So what we're doing with the technology on top of the yield increase is we're also reducing the variability in those more stressful areas of the field. Here's another example of using Terramar, as any grower may use Terramar in combination with other things in that tank mix. So here we're talking about potassium. And you can see earlier where we talked about that increased potassium uptake. Here we're using two potassium products, Reax K and Locomotive, alone or in combination with Terramar. And you can see for stem diameter and collar height, when we combine Terramar with these foliar potassium products, we get a better result, indicating better nutrient use efficiency with the Terramar technology. This is a real world scenario, just like we just talked about with Terramar plus a Foliar K product. This is a pivot from Sedgwick, Kansas last year. The grower standard practice, 207 bushels. Just by adding the potassium product, we added 12 bushels. But when we add Terramar to the potassium product versus the grower standard, we added a whopping 33 bushels over the grower standard practice. So let's quickly give a quick summary. Terramar should be considered for any production system or any production plan. It doesn't have to be only stress. It could be these ideal conditions where we're trying to take that crop to the next level. The two things we talked about today is how does Terramar build photosynthetic capacity, and then how do we preserve that later in the growing stage. Also, combine this technology with other things that we're doing. Foliar K products, our plant hormone, Radiate Next products, other nutritionals, fungicides, herbicides, any crop protection or other crop inputs that we're doing, Terramar is designed to help make that work better. And then we've got flexible application times, early vegetative through late reproductive stages. Terramar is a fit in all scenarios. I want to thank you guys for joining me today. Today we talked about Terramar and how we can build and preserve our yield potential and photosynthetic capacity. Thank you.